Welcome to lesson 2.2, simplifying radical expressions. Alright, let's get started. I'm going to recall the multiplication property of radicals, which is square root with index n of ab is the same as the square root, still index n of a times the square root of index n b. You might remember this from previous lessons. So this is the product of a and b, and we can split that up when they have the same index, as so. And we need to remember that n is a natural number, a, b, and n root a and root b are all real numbers. So let's just dive into some examples right away. Arrange in order from least to greatest. Well, when we look at these, we see that they have the same index, but none of the square roots are the same, and it's kind of hard to decipher which is greater than which. So let's put them back into their whole radicals by using the multiplication property that we just talked about. So 5 root 2 is the same as square of 5 is square root 25 times root 2, which becomes 2 times 25 is root 50. Okay. 2 root 5 is the same as writing 2 squared is 4 square root 4 times square root 5, and 5 times 4 is 20. And 4 root 3 is 4 squared is square root 16, and root 3 times 16 is square root 48. Now here we can see that 20 is less than 48, which is less than 50. So our final answer can be that 2 root 5 is less than 4 root 3, and which is less than 5 root 2. Now we've ordered them from least to greatest. Let's try another one. 7 cube root 2, 5 cube root 2, and 9 cube root 2. Well, the first thing I notice is that our indexes and our radicals are all the same. So we don't really need to compare that because they're all the same. We could just go right ahead and we can compare coefficients. So looking at that, I notice that 5 is less than 7, which is less than 9. So we can order these radicals as 5 cube root 2 is less than 7 cube root 2, which is less than 9 cube root 2. And that's that one. Alright, next one. This one has a combination of different indices and radicals. So to compare this one, we're going to have to use a calculator here. So let's look at our first one, 8 root 5. Let's pull up our calculator. 8 square root 5 equals 17.888, etc. So we're going to write 17.888, so on. Our next one, 4 square root 3 equals, bring our calculator back up. We're going to go 4 times the square root of 3 is 6.928, etc. And lastly, our 3 cube root of 7 equals, get to our calculator, 3, we need to go into our math, cube root 7 equals 5.7387. 5.7387, etc. Looking at what the exact solutions are, we can say that 3 cube root 7 is less than 4 square rooted 3, and 8 root 5. And there we go, that's that. Next we're going to look at our division property of radicals. So it is similar to our multiplication property, just with division. So our nth square root of a over b is equivalent to writing the square nth root of a divided by the nth root of b, where our n is a natural number, and a, b, nth root a, nth root b are all real numbers, and b cannot equal 0, because you cannot divide by a 0. Well, let's look at an example of that. Square root of 25 divided by 9 is equivalent to the square root of 25 divided by the square root of 9. So let's look. Square root 25 divided by 9 equals the square root 5 over 3 times 5 over 3. Right? Well, that's just saying that 5 over 3. And the square root of 25 divided by the square root of 9 is just the square root of 5 times 5 over the square root of 3 times 3, which is just 5 divided by 3. And we have the same, proving the division property rule. So let's do some examples. Example 2. Write each radical as a mixed radical or as an entire radical. All right. A. The cube root of negative 24 over 54. So since this is a cube root, that negative is allowed to be there instead of with a square root. Oh. Let's use our division property rule. Let's split it up. So the cube root of negative 24 divided by the cube root of 54. Now we can split up negative 24 into negative 8 and 3. And we can split up 54 into 27 and 2. We can simplify even more. We can split up negative 8 cube root times cube root of 3 using our multiplication property rule. And same with the bottom. 27 cube root times the cube root of 2. Now negative 8 and 27 are perfect cube roots, so that becomes negative 2 cube root over 3 cube root of 2. And leading that as a whole radical, we'll have negative 2 over 3 times the cube root of 3 over 2. That is our final answer. Let's try another one. 5 square root 3 over 5. Okay, let's try and put this all together. So the square root of 5 squared times the square root of 3 over 5. That becomes square root of 25 times square root of 3 over 5. Putting that into 1, we get 25 times 3 over 5, which is 75 over 5. Simplifies to square root of 15. And there's our final answer. It is important to remember to apply our multiplication property and our division property rules for simplifying and solving these kinds of questions. All right, moving along. All square numbers are greater than or equal to 0. So the expression square root x has a real number value only when x is greater than or equal to 0. That is, square root x is defined for all x that are real numbers and x has to be greater than or equal to 0. So, but looking at the cube root of a positive number is positive. The cube root of a negative number is negative. And the cube root of 0 is 0. So the expression cube root of x has a real number value for all values of x, which is much different than when we're looking at the square root. So that is, the cube root of x is defined for all values of x. Look at some more examples. For which values of the variables is each radical defined? So our first one is a square root. So we need our 48x cubed to be greater than or equal to 0. We can already say that 48 is greater than or equal to 0, so that's good. So now we need our x cubed to be greater or equal to 0, and hence our x to be greater or equal to 0. So our square root of 48x cubed is defined for x to be greater or equal than 0. Alright, part B. The cube root of 15x to the 4. Yet again, we need our 15x to the 4 to be greater or equal to 0. Again, our 15 is already greater than or equal to 0, so that's good. But now looking at our x to the 4, we need that to be greater or equal to 0. This is an even number, so for whatever value of x put into there, it will always be greater or equal to 0. So we can say that the cube root of 15x to the 4 is defined for all values of x. Perfect. Let's do a few more examples. Simplify each radical if possible. For which values of the variable is each radical defined? Alright, part A gives us square root of 45b squared. So, first thing I notice is we can apply our multiplication property rule. 45 can be split to perfect square 9 and 5 with b squared. Now when we're taking out our 9 perfect square, we can also take out our b squared. But remember, the square root of a variable squared is the absolute value of the variable. So we're going to write this as 3 square root 5 absolute value of b. And that'll be our final answer. But we must define our variable, and our square root 45b squared is defined for all values of x, because x is a square, or an absolute value. Perfect. How about b? The fourth root of 7x. Well, we can't simplify our 7 nor our x here, so we can go ahead and just define for our variable because we cannot simplify. So 7x has to be greater or equal to 0, and we already know that 7 is greater or equal to 0, so that's fine. Hence we need our x to be greater or equal to 0. So we can say that the fourth root of 7x is defined when x is greater or equal to 0.